We're now going to have a look at how to calculate the proportion. Now, there are two proportions to be looking at, and just to remind you, we have two formulas. One is for the population proportion. So we're looking for a particular attribute. If we know how many members, or we can sort of estimate how many members of the population have that particular attribute and divide it by the size of the population, then that would give us the population proportion. Related, p hat, we have the number of members with that particular attribute in the sample that we take divided by the sample size of members. Okay, so in other words, the number of people that we have sampled. So we've got an example here. These are real numbers. There are 58 methods for students, 42 of whom are currently taught by Jane. 30 students are selected at random. So maybe I've got a spreadsheet of all your names and I put a random generator onto it, like I showed you in class, and then I pick the top 30 students based on ordering the random numbers. Now, when I look at that list, 21 of those students belong to one of Jane's classes. So question A is, what is the population? So the population is just, well, where are we selecting from? Not from the whole school, we're only selecting from the methods for students. So the population is 58. So on slide 7 there, what is the value of P, the population proportion? So again, the population proportion is the number of members with the attribute over the population of members. Okay, so the population of the members, so P is equal to, well, we've got 58 methods for students, so that's 58 on the bottom, that's the full population, and 42 of whom are currently taught by Jane, and so the fraction is 42 over 58. And you can use a calculator to determine what that is as a simplified fraction. I think it's just 20, let me think, 21 over, that's pretty bad, isn't it? 21 over 29, I think, is as simple as you can make it. So that's the population proportion. So the next part says that 30 students are selected at random. 21 students belong to one of Jane's classes. This allows us to work out the sample proportion. The sample proportion is p hat. On top, we have the number of students who, in the sample, that have that attribute, and the attribute in this case is one of belongs to one of Jane's classes. So that's 21. And then we have 30 students is the size of the sample, so it's 21 over 30. I have to say, I just made these numbers up. Well, the bottom numbers, the 30 students are selected at random. And we can see that the population proportion in this instance, so the sample proportion, is almost identical to the population proportion. That's just happens to be. I could have done another randomization list, a randomization, and chosen 30 students, and maybe only 15 students belong to one of Jane's classes. Or maybe all 30 students belong to Jane's classes. Unlikely, but possible. So the fact that I got 21 and 30 is just happenstance. But remember that the population proportion, P, is constant, assuming the population remains constant. And then p hat, the sample proportion, will change every time. It could be the same or it could be different every time you select a new sample. So constant doesn't change, variable changes each time you change the sample. This time it happened to be almost identical, but that is just a fluke.